Hey everyone, good night. I had a busy day today, so I don't have so many time to do leetCode today. If you're new here, uh, welcome. I'm Jack. I'm working at Tokyo, and I want to get into Google, so I'm practicing leetCode, uh, practicing algorithms problems in on leetCode. I'm a JavaScript engineer. I'm not good at algorithms, so most of the things I learned at college, I basically forgot them all. So I'm doing this. This is my third day of doing it. This is and I'm gonna take a look at the question number 5, the longest palindromic substring. So the question is, given a string S, find the longest palindromic substring in S. You may assume that the maximum length of S is 1000. So the example is BABAD. We should return BAB or ABA because either way you read it in normal order or in a reversed way. They're all the same. So another example is CBBD is BB because BB. Either way, you are getting the same string. So how can I do it? So let's look at the first analysis. The brutal force way. So how can I do this? Let me see. So to check a string of ABCD to see if it is palindromic or not, like example ABCDA is palindromic or not. How can I do that? So I have to traverse all because sorry, I changed the font larger. Okay, no larger. Wow. Because traverse all. Yeah, basically all, but maybe we can improve that. We don't know what there is, what there are in the latter half. So let's say if we got, I'll just put it under it and remove the command. So the first time we got is A. This, of course, it's palindromic. Minimum. And if we get AB, it's not. Yeah. Okay. Brute force way, so we traverse all the digit, all the letters, all the characters. This will be O-N. So in each round, traverse the rest of the string and check the like let's say use I. You in each round traverse the rest of the string. J I plus 1, J 2, 2 n minus 1. Take the string, check if palindromic of S I as I J. So this will be, if it is palindromic or not. Basically, we'll have to check j minus j minus I. This will cost us this time amount. So when we count them all, there will be a difficult, not a slight complicated calculation, but I think when the j is small, it will have a fewer time to compare the palindromic string, but if j is bigger, it has more. So generally this would be, without detailed calculation, this will be on. So the general time complexity is on square. So let's improve it. So to improve it, we have to put some examples. So improved. Let's just say A, B, C, D, C, B, D. It's turned slightly like that. We're gonna be a long palindromic string like this, A, B, C, D, C, B, but I'll change it to B. Okay. Now first we take A, 1. AB. Let's take it A as a start. So A, AB, ABC. No. ABCD. I'll remove the double quote to make it faster. A, AB, ABC, ABCD, ABCD, C, BCD, CB, ABCD, CBB. And then I choose B. So it's gonna be C, BCD, BCDC, BCDCB, BCBB. Wow, this is really time consuming. CB, CBC, CBCBB, CBC, BB. Let's take a look at the flow and check if it has something we can improve on. How can we do it? So for A, for this round A, we don't for this round we don't know. The thing is that I slightly think that say that because there are 7 letters, so if we folded this string at the center of this string, like here, we can check I have a slight feeling that we can stop checking after half of the string. So I mean ABCD, if we find ABCDB it's not, we can stop because there's no possibility it will be like this, right? No, I'm sorry. If this, we don't need to check. And BCD, and for B, if we got the largest longest string, already got the long string, we can skip this the length. Say we got ABC, there's none, so we just continue, but there is BC, DBC, BC, DCB. And then we don't need to check this because we just jump to the last one, the longest one. But there's a possibility that there's not all of them. All of them are not palindromic, right? What if we, because palindromic, it is symmetric. Maybe we can find another way to take a look at this. So considering all those possible the center point, we may take the center point as A and space A, B, 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 C, C, and so on, right? And we can check each of this point. We can check each of whether this point matches our goal, matches our condition. Like for A, there's nothing left and nothing right. I'll keep this one. We find a new one. So A, there's nothing left in the left, so it's gonna be 1. And for A and B, there's A and B, right? We check it once, and we update it to 0. So we do nothing. For B, there is AC. We check it 01. Let's fail, so do nothing. And we got BC 01 AD because we compare AD. So and we said C OC, we got BD 01. But D is different because we have CC okay, BB okay, and stop at AB. So 02, 03, and then we update it to 5. Does this sound good? So generally for 02N, what times each time we will check 2.5. So it's gonna be O generally and 2.5. So it's still O n squared. It doesn't improve. Doesn't improve. Let's take a look at the because it's symmetric. Let's say that for a string, hold on. So a string is with length n, and the center point is at I. Yeah, the palindrome is I and j. So what would be the characteristic we can use? So if pi and pj is largest palindromic string in Sn, so pi minus 1 and pj plus 1 should not be the same. Yeah, of course, if it is, it won't be the largest one. And what? Oh shit. Wait a minute. Pi and pj won't be the same. So it doesn't help much. A, B, C, D, C, B. So for the above string A, B, C, D, C, B, B, how can we find it? Could we remove the string from left or right? Or let's say if this is the Sn, what would happen if we add a new one? So if we go to Sn to Sn plus 1, what will happen? Like A, B, C, D, B, C, C, B. If I add a new one, like because A is not, because pi will not be pj plus I. The only way of creating a new palindrome, a new longest palindrome, is that so the center point should be on the right. It couldn't be on the left. Why? because what? X. This is the longest palindromic. So these these two characters should not be the same. But if we add a new one, if there will be a new palindromic, what would be the what would be the string B? What would be the longest palindromic string B? It couldn't be the original one. Okay, it couldn't be the left one. If so, let's say we'll pick it this way: 0, 1, I, the j plus 1, I minus 1, and this should be x n. Okay, so if this is the longest one, these two are not the same. If we add a n plus 1, if so, generally the longest one should be the same, but if it generates a new one, it should be something I think on the right. If it's on the left, okay, so if it's on the left, it means because we only add one, because we only add one character, it could only be moved. The could cover one more. It couldn't. If it covers two, then this should be the longest palindrome, right? So if it generates a new palindromic, the new number should be included. If not, it doesn't matter. So this will be a new one. So if it generates a new one, let's say if it is a new palindromic string, so now n plus 1 come, it gotta be a new palindromic string array of m and n. But it should be with n plus 1, so it should be p m n plus 1. This is a new palindromic string. So it could be, so let's say where is the m? If we find it, if we could found, okay, it's possible that here, and okay, it's possible here. If it is possible in J, if it's M, so we have this m plus 1 minus n is bigger than j minus I. So m is smaller than n plus 1 minus j plus I. So m must be smaller than here. So we just to check that to see if there is a palindrome string, right? So to check that, we will just check if it's this one, this one, this one, until until this. It's, wow, I'm stuck. I'm tired. I'll look again at A, B, C, D, C, B, B. What if we the longest one? So n plus n. When I check A, B, I don't know whether it is more palindromic, so I have to see them all. But I already got B, C, D, C, B. If I got this, maybe I don't need to check B again, right? Because if this is the longest string, I don't need to check B. or if I can, oh, usually, oh, but this only checks whether A, B, C, D is not whether they are. This means the longest palindromic string from A. This is from B. Hmm. Hmm. After think, I think maybe this is promising. So I think I'll just try on this way. But maybe I'm getting wrong. I'll calculate the time complexity. I'll write a new helper function. Is that var check palindromic equals. I'll write in new way, ES6 way, IJ. So check palindromic at. So this is the center, so I would say it will be max n. So it's very simple. So while I is larger than 0 and j smaller than n minus 1, if this is true and if they are small, I'll say let result equals result. Okay, the result is ij. So while there is I is bigger than 1 and this is the length, I think. S length and si equals sj. If they are the same, I'll just I minus 1. Yeah, I say j minus plus 1. And then I return I and j. So this is the palindrome, right? And I'll say result equals 0 0 if s length return 0. So there must be something in the array, and I'll start with 0 0 0, and how can I loop? First one is 1 1, and then 1 2, and then 2 2. First is 1, and then one, 2, 1, 1, 2, 2, 2, 2, 3. So I'll just in each loop I'll check twice. Result if j minus 1 is bigger than result 1 minus result 0, return j I, return result. So I'll say 1 and then 2 and then the last, right? So let I equals 0 while I is smaller than is the length. I'll say I'll check palindrome at first I'll check at I, so it should be, wait a minute, plus plus. I'll check I and then I and S and 0 result. But result is value, right? No, it should not be. Should not return, just to update the result. Result update is number, it's object, so it should be it's 0 should be I, so it's 0 should be J. Okay, so now I'll just traverse them all. I'll start with okay, post result equals 0 0 and then I'll say result, and then I'll check it again at because I take the first one 0 0 and then I take 0 1. But if I is smaller than S minus 1, so I'll only check this again. Palindrome I plus 1 as result, and then I'll return as a slice result 0 result 1. Well, I don't think it works, but why I say BABAX? I'll say I'll just also log ij result 0 0 0 0 0 1 0 0 1 1 1 0 2. I'll say slice ij. Oh, sorry. That's one, come on. B, B, A, no, okay. Then I say A. Sorry. I did a break here because I need to check if it matches. It is a palindrome, right? So this will just stop at something that is not palindrome. So it should be minus 1 minus I plus 1, so minus 1. I make it I plus 1. Okay, so B 0 0 BA 0 0 A 0 0 AB 0 0, and then I say B 0 0, and then BA I say B is B, and because A is big, so it should be JD 4 1. Okay, so I made a mistake here. I plus 1 3. So and I slice plus 1. I don't think this runs fast enough, but maybe it could be a accepted run answer. Sorry. BB B, but except 2 BBs. I'll say B C. First B, and then BB plus 0 1, and sorry, I shouldn't do this, but if I minus 1 is bigger than 0 and J plus 1 is smaller than S10, then we can do this. Oh, but it don't break, right? Oh shit. I should say this one, right? Yeah. What? I wing? I don't know. I ran faster than 90%? So, I don't even know what happened. Wow, man. Is this fast enough? But this is very clear. This one, just check. Let's see, look at official common mistake. Some people will be tempted to come up with a quick solution, which is unfortunately flawed, however can be corrected easily. Common substring. Just compare, right? We could see that the longest common substring method fails when there exists a reverse copy of a non-palindromic substring in some parts of S. A, B, C, D, A, B, C. To rectify this, each time we find the longest common substring candidate, we check if the substring indices are the same as the reverse substring's original indices. If it is, then we attempt to update the longest substring found. If not, we skip this and find the next candidate. This gives us an ON dynamic programming solution. Dynamic programming solution. We choose ON here. ON square here. Could be improved to use N in one space. ON space. Please read more about longest common substring here. Brute force. Brute force. This basic brute force solutions pick all the possible starting and ending to verify it is a palindrome and total substrings. Since every finding each substring takes its own time, and one time it costs N3 and on cube. Why? Substring, there is this kind of substring. A, B. Yeah, there, N substring. I made a mistake. Yeah, it's O and square. Cubed. Dynamic programming. This is dynamic programming. To improve our brute force solution, we first observe how we can avoid unnecessary recommutation or validating palindrome. Consider the case ABABA. If we already know that BAB is a palindrome, it is obvious that ABAA must be a palindrome since these two left and right are the same. Their PAJ as follows. False, that's why. Therefore, PIJ equals PI1J minus 1. IJ, PIJ, and S1. Therefore, the basis cases are true. So PII plus 1 equals SI equals SI1. See the straightforward DP solution, which you first initialize the 1 and 2 letters palindrome and works our way up. this you the straightforward TP solution? Yeah. So pi plus 1 I. You should. I kind of understand what the dynamic programming means, but I cannot explain it now. So it means, let's see if one. It's just this. It's just actually it's a improved brute force, right? So actually it says I'll save whether they are palindrome. So when you check another another string of if it is palindrome or not, it will just check the one before. Yeah, you see, if I want to check each I and j, if it is a palindrome, I will just check these two and compare the letters and check if they are palindrome. But they are this one. I can see j is small. There must be checked, and the I plus 1 is bigger than I. It's also checked because it's between these I and j. Yeah, time is O n squared. I want to write the code of in this dynamic programming. Yeah, you see that this is improved the brute force solution. So you just avoid recompilation, and we need just save the result in an extra space. For the brute force, it has only space capacity of 1. There's no extra saving. But here we need, so it will n square. Expand around center. In fact, we could solve it in O(n) time using only constant space. We observe that a palindrome mirrors around its center. Therefore, a palindrome can be expanded from its center, and there are only 2 n such centers. You might be asking why there are only 2, not n centers. Well, man, I haven't. I happened to done the last one, expand around center thing. I made a mistake at first that I said the brute force just got us n square, but actually it has the complexity of n cube. Let's take it again. A, B, C, D. So A, and then I'll check A, B. But for A, B, if I should check it, I will check it twice. Check it once. So A, and then I'll check A, B, C. But this will check twice. And then A, B, C, D, I'll check twice too. So actually this is B. So So it will be n times this, n minus 1 Okay, I'll say it's I and the times n minus I and times n times j minus I 2 and sigma sum. So this should be actually yeah, this is n, this is n, this is n. So n cube. But our solution, why it is n square? Because we'll have the first one will traverse all the points. It's actually 2 times n. It's okay, and then we check each point and expand them to whether they are palindromic or not. So we just expand it and here compare it and expand it, and we update the result. Wow, cool! We just happened to to finish it. This is lucky, or I don't know. I made a mistake of calculating the complexity. I need to do it better next time. So okay, thank you guys. So this is for today. Hope to see you soon. Bye bye. Have a good night.